Bring it from the bottom. Thank God it's Saturday. No, I'm not Eric Thomas. I'm here back with you with another exercise to check out here. Today we're looking at count the divisors of a number from Codewars. Once again, this is a Python exercise. You see good old Python right here in the selection. And yeah, this is count the divisors of a number. This is a pretty simple exercise, and it'll be a pretty short one, but it's good practice for some of y'all out there. Maybe good practice for me explaining it. Looking at the explanation here, or the instructions, really you can just really drill down into the examples, because this is a simple enough idea where, given a number, we're going to count the number of divisors in that number. Basically, the numbers leading up to that number that are evenly divisible, I guess, by it. Or I don't think I said that right. But these are the divisors. It's still pretty early in the morning here. For 4, we got 3 divisors, 1, 2, and 4. For 5, we got 2 divisors, 1 and 5. So the divisors will always include 1. Everything is evenly divisible by 1 and itself. So actually that's another point where we're going to include 1 and the number. So this is inclusive, because sometimes when you get divisors, it's going to be like the in-between. Maybe it's 1 up to the number not including, or the numbers between 1 and whatever. But this will be, I guess you could say, all-inclusive. So you get the divisors, but really you're just counting the divisors in this situation. So we're counting the divisors and returning the number of divisors. We're not actually returning the divisors themselves. I will erase here. Is it working? Yeah. I'll start with this code, because this will be, I believe this one will be kind of short and sweet. So get my cursor back here. Going over here into the work area. I'm going to first create an integer to hold the count. Make that equal to 0. And I got one more thing to erase over here. Just want to tidy that up. Housekeeping. Oh yeah, I'm going to make a count equal to 0. And then I'm going to do this in a while loop, because I feel like while loops are, well, in Python, the while loop, the condition is very configurable, whereas in the for loop, the condition's not configurable at all. So really for this, you got to use a while loop in Python. Because, we're going to loop and get the divisors, of course, right? So with while, you've got to kind of manually set your I, your iteration variable to something. So I'm going to start with I is 2, because I already know that 1 is going to be a divisor. So I don't even need to get 1 as a divisor. I can just start with 2 and see if 2 is the divisor. Start with 2, because 1 is already a given. And also because of that, I remember my count is going to start at 1, because 1 is already a given. Meaning that 1 is a divisor already, so we can always start our count at 1, because that is for the number 1. Number 1 is already going to be a divisor of everything, so our count can start at 1, and I can start at 2, because we don't need to check if 1 is the divisor, because it is already. So we'll start the while loop, and we'll loop while I is less than or equal to n. N being the argument here, of course. And the equal sign is here because we want to be inclusive. Remember I said inclusive. We want to include the number itself, and really thinking here, we already know that the number itself is going to be a divisor. So I could actually just tack it up to 2, count up to 2, and then make the equals not equal or like that. That's what I mean. I'll just go ahead and do that. And see if this works. Okay, so how do you find divisibility? Divisibility is found with the modulo operator. Remember that the modulo is the remainder of a division between two numbers. Well, if you do a modulo operation and the remainder of the division is 0, then that number is divisible. So we can set up a condition for that. You guys love the typing sounds, I'm sure. The type of the keyboard is pretty close to the microphone. So yeah, our number n, if n modulo 1 is 0, meaning if n divided by I is, if n divided by I there's no remainder, then it is divisible. And if it is divisible, I will increase my count by 1, because that means it's divisible. No need for an else, because if it's not divisible, it will take no action. What is left is to increment I by 1, so we continue the loop. This is a common thing that some people forget, where if you don't have this, you will have an endless loop. I'll put a little comment there, little question mark up there. And this is pretty much it, because once this loop is done, we've got our count of divisors. And I will just return this sucker and see what we got. Oh, this is funny, yeah. I wonder if you guys caught that. Coming back and forth between languages, I was doing C++ or Java instead of Python, where I was declaring my data type, where I don't need to do that in Python. So I wonder if you guys caught that early on. This has been sitting there for a while. We all make mistakes, hey. All right, 2 should equal 1. Yeah, I forgot about this, because I think this would be in the case of 1. So let me change that. I think if I change this, this will be taken care of, because this failed because of 1, and you don't want to count 1 twice, you know, so you guys figure it out. All right, that works. I'm the teacher, right, and I'm telling you to figure it out. But I'm a little pressed for time, so can't explain it all. You guys can sign up on my program if you want a full explanation of what I just did. Alrighty, that's a good one, and that's done. And I'll do an erasure real quick. And yeah, there's a complete solution. Got the green, so we're good to go. Got the dopamine hit, ready to go, ready to face the day. You guys have a good one. I'm out of here, and this is another exercise. Toodaloo. See y'all on the flip side.